Practice test 1A looks a lot like this document that you can see here in front of you. Mr. Shane today is going to go through each and every one of these problems to help you prepare for what would be practice test 1B. You're going to notice with our tests and the way in which we take care of each of these different assessments is that as we go through a practice test, you're going to find that each problem corresponds with the next test. So this is practice test 1A. The actual test that will be graded for your assessment would be 1B. Now number 1 on test 1A is going to be really similar to what it looks like on test 1B. So by doing this together, following along and doing each problem with Mr. Shane, you'll better understand how to then complete that, not only in this sheet live with the video, also when you're taking your test tomorrow, you may use this as a resource. Let's get started. Number 1 says, a burst of electromagnetic radiation has a frequency of 1 exahertz. 1 exahertz equals 10 to the 12 megahertz. Each megahertz equals 10 to the 6 hertz. What was the frequency of the burst of radiation in hertz? Well, in this case, it's asking us to multiply each of those values. So we have 10 to the 12th and 10 to the 6th. I would fill in the 12 and the 6 here in the little blanks that are provided. You sometimes have a little hint or a little formula for us to use. We know that this is our product property of exponents, so we have the same base. We're going to add those together. 12 plus 6 is going to give me 10 to the 18th, my total as hertz. Number 2, identify the factors and coefficients in the expression. In this case, you have two factors, things that are being multiplied together, and you have one coefficient. Our coefficient is the letter itself. Factors would be what's being multiplied. Well, in this case, you have m being multiplied by what? What is over 2? Whenever something's not written in that place, we're going to put in a 1. So these two items right here would fall into the category of what our factors are. I would write those right there. M and 1/2. You can write that with a multiplication symbol or a comma to show that those are both factors. In number 3, a rectangle carpet is 9 feet wide by 12 feet long. Its area is 9 times 12 in square feet. A circular carpet has a radius of 4 feet. Its area is 3.14 times 4 squared. How much larger is the rectangular carpet than the circular carpet? Find each area and subtract to find the difference. So to do this, you're first going to find the area of the rectangular and then area of the circle. Area of the rectangle is going to be 9 times 12, and the area of the circle is going to be 3.14 times 4 squared. So it gives you each of the different parts of your calculation, and you'd go about carrying that out. 9 times 12, or 12 times 9 is going to give you 108. 3.14 times 4 squared. 4 squared is going to give you 16, so 16 times 3.14. You have 16 times 3.14 because 4 squared equals 16. That's going to give you a total of 50.24. Now if I'm going to go about subtracting those values, say how much larger is the rectangular carpet than the circular carpet. Remember, this was our rectangle value here, this was our circle value here. If I subtract those two, you would write it out 108 minus 50.24. As I write that out, I would have the zeros provided. 108 minus 50.24 gives us a total of 57.76 feet squared, because we're dealing with multiple feet. When you're multiplying both of those together, you come into the term of being feet squared. In number 4, identify the terms in the expression. The first term is right here, the second term is here, and the third term is here. So all you have to do is write those items down in those actual locations. The first term is 3ab, the second term is 7c, and the third term is 9b over 2a. Number 5, it says simplify 1 to the 11th squared. When we have exponents, it applies to both the numerator and the denominator. So you would write this out, 1/11th, because it's multiplying this twice and multiplying this twice. 1 times 1 is 1, 11 times 11 is 121. In number 6, it asks us to simplify using the order of operations. I'm going to give you a minute to try and remember what those order of operations are. What is the acronym that is used for calculating and completing order of operations in the correct method? If you said, please excuse my dear Aunt Sally, you've got that correct. Or PEMDAS is our parentheses, exponents, multiplication, division, addition, and subtraction. We'll give you the correct order of operations. Now let's apply that skill and that knowledge to solving this problem. Here we would follow PEMDAS and use parentheses first. You've got 2 times 7, which is going to give you 14. You've got 3 plus 4, which is going to give you 7. Now, if I rewrite that, I would have 14 plus 4 times 7. Now, sometimes we'd want to add these together just because they look like they're really simple, easy to do, but you actually have to do 4 times 7 in this case first. 4 times 7 is going to give you 28. Plus 14. 14 plus 28 gives you a total of 42. In number 7, it asks you to simplify with our absolute value symbol. And then it reminds you with a little hint here. First simplify within the absolute value bar, then find the absolute value. So inside of it, like our parenthesis, we're going to solve what's inside first. 9 minus 7 would be 2. Absolute value symbol stay, and the negative sign is on the outside. The absolute value makes whatever's on the inside positive, so this would be a positive 2, but the answer and the result is still going to be, negative 2, because that negative is on the outside of that actual value. In number 8, you're simplifying using the product property of exponents. If you have the same base, you can add up the exponent. I'm going to separate these two so that you can see the difference between those different numbers and not adding up the wrong numbers. For each one that you have an A, you would add up these values in the exponents. 2 plus 3 plus 5. 2 plus 3 is, 2 plus 3 plus 4. 2 plus 3 is 5, plus 4 is 9. B is 5 plus 3 is 8. And I write those next to each other because they're being multiplied as if they are factors. In number 9, it asks us to simplify this expression. Again, we're going to use our order of operations and our symbols of inclusion in this case. Symbol of inclusion would be the fraction bar. Here we need to solve what is in the numerator before the denominator because they're separating into two sets of problems. Inside of that numerator you have parentheses and you have an exponent. We'll start inside of the parentheses. 2 times 4 is 8. And you have 8 minus 5 inside of those parentheses. We'll solve this one step at a time. 8 minus 5 is going to give you 3. 3 is going to be cubed. 3 times 3 is 9 times 3 is 27. 27 over 9, can I reduce? 27 divided by 9 is going to give me a total of 3. Number 10, simplify the expression 0.2 inside of parentheses with the exponent of 5. The exponent of 5 indicates that the base is the factor 5 times. So if I'd write that out, it would be 0.2 times 0.2 times 0.2 times 0.2 times 0.2. 1, 2, 3, 4, 5. Now I would multiply all those together. I'm going to use my number sense and say that every time I multiply by 2, I know what that value is. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I get an answer of 32. Now how many decimal places did I have when I was multiplying those decimals? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I would add in those overall decimals. So I get 0.00032 as my answer. Flip it over. Number 11, a babysitting service uses the expression 9.0h plus 15.95 to determine the amount of charge for a single session. How many terms are in the expression? Identify the constants, identify the variables. Well, terms are going to be separated by our plus or minus sign. So here you've got the plus sign, there are 2 terms. Constants are going to be the numbers, and the variables are going to be the letters represented in each. In this case, the constants are 9.0, comma, and 15.95. The variable is going to be the letter that represents a number, that is h. 12. Identify the subset of real numbers to which the number 2, the square root of 7, belongs. In this case, we automatically recognize that all numbers fall into the set of real numbers, and then you're looking to break that down even further. Because this has a radical symbol in it, you're going to call that an irrational number. Number 13, identify the set of numbers that best describes the amount of a bill, including a tip at a restaurant. Explain your choice. So you're out to eat. By the time you're done, they're going to bring you the bill or the check, and you're going to look at what that amount is and then identify what subset that is for number 13. This would probably be the best set of rational numbers. Best describes the situation because if you have a amount as a bill, you're talking in terms of money, but as it includes a tip, a lot of times you're going to get into probably what would be the change, so a coin amount at the end of your overall bill. That would then put you into the decimals. So the set of rational numbers best describes the situation because of decimals. 14. Identify the set of numbers that best describes the area of a circular skating rink when the radius is a rational number. Explain your choice. Now the dead giveaway here is circular. Anytime we're calculating area of a circle, we're going to use our friend number pi, which is equal to 3.14. But when we use that symbol, it's a dead giveaway to say that the set of irrational numbers is best described situation because you're multiplying that radius by pi. Pi is our calculation that gives that as an indicator for irrational numbers. Number 15, it asks us to practice our addition. 4.1 plus negative 6.3. In this case, when we're adding real numbers, you need to make sure that you keep in account those signs. If they are different, it's different, different, subtract. Different, different, subtract, and you keep the absolute value of those values. So 6.3 minus 4.1 is going to give you 2.2. Now, is that positive or negative? Remember, keep the sign of the number with the larger absolute value. Larger absolute value would be this value that has a negative sign, so our answer is going to be negative 2.2. Number 16, the temperature at 6 a.m. was negative 2 degrees Fahrenheit. The temperature rose 10 degrees Fahrenheit by noon. Use addition to find the temperature at noon. So if you were at negative 2 degrees and you went up 10, it said it increased by 10 degrees, you'd say plus 10. What's the answer to negative 2 plus 10? Different, subtract. Absolute value would be 10 and 2. Subtract those. 10 minus 2 is 8. And because the absolute value of 10 is a larger absolute value than negative 2, your overall value is going to be 8 degrees Fahrenheit. I'd write that out and say it like this. Negative 2 degrees plus 10 degrees equals 8 degrees. Notice how, as I'm showing my work on the side here, it's actually providing the blanks for me to put those things in, those nice little neat hints to keep us nice and organized with our work. Number 17, compare the expressions, solving on the left-hand side and the right-hand side, and then using our greater than, less than, or equal to as our comparison. Here you're following your order of operations and symbols of inclusion. Start on the left, 2.5 plus 4 divided by 5 plus 2 cubed. First thing that I'm going to do is my parentheses, so I have 2.5 plus 4. That gives me 6.5. Divided by 5 plus 2 cubed. Now I'm going to do this in one step. I'm going to do 2 to the third power because that's technically next. After parentheses, we have exponents. 2 times 2 is 4, times 2 is 8. So I have 6.5 divided by 5 plus 8. Let me write this correctly. 6.5 divided by 5 gives me 1.3 plus 8 gives me 9.3 for this left-hand side for number 17. On the right-hand side, we would separate our symbols of inclusion and say that the first thing we're going to do is the parentheses on the numerator of this fraction bar, then we'll combine and do our division here. 16 plus 12 gives me 28. And now I have 28 divided by 2 minus 6 divided by 2. I'm going to reduce with both of those division problems first. So 28 divided by 2 is going to be 14. 6 divided by 2 is going to be 3. 14 minus 3 is 11. And 11 is larger than 9.3, so my allocator goes this way and consumes the large number. 18. Identify the constant variables in the expression. 3ab plus 2x. Our constants are going to be our numbers. The variables are going to be our letters. So the constants in this case are 3 and 2. The variables a, b, x. 19. True or false? The set of natural numbers is closed under addition. If false, give a counterexample. If closed, the outcome is a member of that given set. So if it's closed, when I'm adding a natural number to a natural number, I get another natural number. So let's do some math in our head. 2 plus 2 is 4. 3 plus 3 is 6. 5 plus 5 is 10. 5 plus 2 is 7. Each time I'm adding two natural numbers, I'm getting a natural number. So let's say this statement is true. Number 20. True or false? The set of whole numbers is closed under division. If false, give a counterexample. So if I divide two whole numbers, do I get another whole number? In this case, you would say that the answer is not true, but in fact false. Because if I have a smaller number that's divided by a large number, I get that turned into a decimal. So for example, let's use 3/4, or 3 divided by 4. 3 divided by 4 is going to equal 0.75. That's not another whole number after that's been divided, so that's false. Well, here's my counterexample. The statement is false, and the counterexample is right here. Now, I need to have a counterexample if it's asking me to give a counterexample. So here's 3 divided by 4 equals 0.75. So showing my work, showing that I've given that example, show that understanding to explain why I came up with that reasoning for false. Now again, each of the different problems on your practice test align with what is on your actual test. So this is 1A. Tomorrow you'll take care of test 1B, and 1B's number 1 looks just like 1A's number 1. 1B's number 2 looks just like number 2 on this test that we did today. The numbers will be a little bit different, the word problem would be a little bit different, but the skill itself that you're doing is going to be very similar in each of the different problems on both the front and back of this. So if you're using this video to help you complete your practice test today, you can use this and the actual practice test form to complete what would be the cumulative test 1B for tomorrow. God's blessings on your assessment. Good luck.